everything together and you're learning how a forecast is written. So before you can write a forecast, before you can do anything, really, you need to know what the weather is. So if I were to tell you, go find me the weather at some obscure location, we'll say, you can't quite get at weather. In other words, if you're driving a long route, one of the main routes in southern Ohio or in parts of West Virginia, there are areas where there just aren't any towns. Very few people live there. And there's probably not an observation of weather there. Yes, we have some satellite, and we can get some ideas from satellite of what the weather might be. But we can't tell you exactly. And when you're forecasting the weather a few days out, knowing the difference in temperature from one location to another at the initial time step can be huge. I just put up a map here with most of the observations we see typically in the area. And you can see there's parts of southern Ohio that have very few. Lots of West Virginia has nothing. A little more coverage up in the central part of Ohio, northern Ohio there. Notice along the ocean, boy, you get out in the water, there's not much. There's a buoy here and a buoy there. There is just not a great deal of information out there. So this is just talking about learning what is good, what is now, what is the current weather, trying to define it. I'll give you an example of what can happen if you don't know the exact conditions very well. This happened about 20 some years ago. There was a forecast that I was working at Sterling, Virginia at the time, and we had a partly cloudy forecast literally for 24 hours ahead. To the south of us, there was a snowstorm and rainstorm going on. To the north of us was a big high pressure system. An observation, an upper air sounding observation at Atlanta was off. That observation was off literally by 60 miles an hour at one elevation. Every other one was right. The models all said that that snowstorm that was down to the south was going to go out to sea. Well, it didn't. It came up. We got over a foot of snow in D.C. area. Yes, we updated the forecast literally 6 hours before the snow began falling and put out a winter storm warning. So there was very little lead time for anybody. There was no winter storm watch. We went back and looked at that same forecast. It was run by a lot of people after that, taking that error into account and applying it. Every time that was done, the forecast shifted. All the snow that we got was well forecasted, literally 24 to 36 hours out. So this is all just for one data point being wrong. You can see having errors that we're not sure of can cause a lot of initial problems in a model forecast, which can lead to problems down the road. So let's do a forecast. Take a peek at this. So what do we have going on currently here? So let's close this window out here. And look at this one. We're going to bring up, this is a forecast for the future based on, put out by NCEP, the Weather Prediction Center, part of NCEP in College Station, Maryland. It incorporates a large area, a lot of forecast information go into it, but it also isn't giving you details. In other words, I see here there's scattered showers, maybe some thunderstorms here in Ohio and Virginia, maybe, in West Virginia here, some potential for severe weather down here in Georgia. Oh yeah, a big area of light, literally snow over Chicago and all, and yet I'm not convinced that that's all what's going to happen at that time, not in detail. In other words, I'd want to know in detail how many hours of that day should I be expecting those showers? When is the highest chance of those showers? So here is that front. It is out here. There's a cold front coming down from Canada into it. Right here, this front is. Temperatures are in the 30s behind the front and 70s out ahead of it. Typical. We're getting into springtime. If we were to look at the overview right now, day one, you see that front? Some severe weather up in Kansas with it. This low is associated, just really doesn't even have a front with it, just almost little tiny boundaries with it. And you can see one moves off, that low gets going more, it's moving to the east, and it's stronger. So if we were to look at models, and models are just taking what you've learned and putting them into mathematical equations that unfortunately we can't solve, so everything's an approximation. And it's an approximation when we don't know all the information at every given point in the world. So with that approximation, let's look at the model. Knowing it's that, this is the upper air model. It's a high resolution and it allows convection, called the North American mesoscale model. High resolution means we're looking at about 5-kilometer grid spacing on this. So it's forecasting every 5 kilometers. You'll see here, if we were to start this loop out, we have a pretty good trough out here in the Midwest, and we got a pretty good jet and a jet streak coming in here, and another one coming over the top and down towards it as well. To the east, kind of a ridge built up here a little bit. So by Sunday, this jet is getting pretty strong across Indiana, Illinois area, and begins to impinge by evening time into Ohio and West Virginia. So if I know that, then what can I learn from that? I know I'm going to have divergence over my area. And we've already just looked, we have a cold front that's going to be approaching our area at that time frame. Let's take a look at another section. We'll come down to 850 millibars. You've all looked at these charts plenty of times now. You're probably tired of looking at them. And what you're seeing here is a very strong southerly wind out of the Gulf of Mexico. Lots of moisture coming out ahead of this front. Here is the 850 front, probably a little behind the surface, but not a lot. And it's actually fairly cool. You know, minus 9 degrees Celsius behind that 850 front, coming into Minnesota. So here is coming into the end of this again. We'll stop it here at the very end. So what I see, we have a very strong temperature gradient. Look at how cold the air is. You know, temperatures are what? Plus 10 or 12 here ahead of this front at 850, which is 5,000 feet in the atmosphere. And they drop off literally to about minus 6 to minus 9 Celsius behind it. So there is 21 degrees Celsius temperature change. 21 degrees Celsius, about 70 degrees. So it is a very strong temperature change going through here right at this time. Also, all that moisture you saw coming up, well, it got cut off. We no longer have all that moisture coming up. So the amount of precipitation that may be going on ahead earlier is not going to be as much. So all this is contributing to a forecast of probably some showers and thunderstorms with this front coming through on Sunday afternoon, Sunday evening, and colder as the front passes your area. Also, this whole thing is slowing down, so it's not going to pass real fast. So this is what goes into everything you have learned is in here in making this forecast. None of this is something we haven't talked about. This is just one of many numerical models. I can show you a home page, and you could be either confused or impressed by looking at it. But and this is a page I like to use. It's from the National Weather Service, but there are other ones out there as well. Here's all the models that I have. Literally, I have over 20 different models to choose from. And I can get even more complicated than that. I know where some other ones are. This isn't even including the UK Met, which comes out of the United Kingdom, or the European model, or the Canadian model. All of those are available on the line. So you can see I can get very confused. We do ensembles of models. The ensembles give you a better idea of what the actual forecast. It also looks at the uncertainty for the forecast. For example, this is an ensemble of one contour. And you'll see there's a little bit of spread. This is a 60-hour forecast for literally when we were talking about that trough there, and you can see the trough in this area of low pressure, but there's not a lot of spread. So this would be a high confidence forecast. Many times you get all over the map this contour might be. And the further out you get, if I push it out here, for example, notice how it gets very confusing. So with time, it gets worse. So hope you got a little bit out of this, and I hope you've enjoyed learning out of what the weather and everything that's involved in it. And, here's just a little bit of a forecast. Let me know if you have any